Hi friends, my name is Nirved. I am a graduate student at UW Madison and I am making this series as a review of level sets. So let's get started. So to to understand level sets, we first need to understand some basic differential geometry. So in this video I'm going to talk about how to find a tangent of a curve. So let's say we have this curve and let's call that curve C, and it is parameterized by a variable theta. So by that what I mean is, let's say if this is a point in the curve and um, it is defined by x and y, then x is given by some function of theta, f of theta, and y is given by some other function g of theta. So I'm going to say let C is given by x of y, x and y, like this, but we have to remember that x and y are actually functions of theta, which is the parameterizing variable. So let's say if this is a point at some value of theta, theta 1, if we increase theta we can reach some other point theta 2, and they will have different x's and different y's based on the theta value. So now to find a tangent of the curve at some point here, like this, so this was supposed to be on the curve, so we have to take the derivative with respect to the variable theta. So what we can think of this as dc by d theta, and then this will be dx by d theta along the x direction, and then dy by d theta along the y direction, and this we are going to just represent as c theta x theta, where the subscript is the derivative, like the variable with respect to which the derivative was taken, and that's our uh, so this is a tangent basically. And now if we want to find a unit tangent, which I'm going to say by, excuse me, so I'm going to say this is the unit tangent, and uh, along the curve. So for this we have to normalize. So we have this c theta, where theta is the variable with which respect to which the derivative was taken, and then the normalization can be given by x theta square plus y theta square. Okay, so that's the unit tangent. And so another way of looking at this is, instead of differentiating with respect to theta, we could have differentiated with respect to the arc length of the curve. So what the arc length is basically the length along the curve. So it can be given by a small part of the arc length can be given by something like this: x theta square plus y theta square, and this times d theta square. So I'm going to move this up a little bit. So this can be given as ds by square root of x theta square plus y theta square d theta. Okay, so now if we come back to this equation, this can also be represented as c theta upon the magnitude of c theta, and this is basically saying ds is equal to magnitude of c theta d theta. Now if we differentiate our curve with respect to the arc length, so if we do c s, so that can be given as c theta d theta by ds. And if we look at this equation 1 and equation 2, we'll get cs is equal to c theta upon the magnitude of c theta. So, and this is the unit tangent. So we saw that the unit tangent can be given by just differentiating the curve along the arc length, or differentiating it with respect to the parameterization variable, which in this case was theta, and then normalizing it. So in the next video we'll talk about how to find the normal of the curve.